We're starting our second to last unit today, Unit 12, Probability. For our first lesson is simply an introduction, so there's some terminology we need to get out of the way and some of the basics. You want to have pages 392 through 394 of your textbook, something to write with, and maybe a highlighter. And your homework is going to be pages 395 and 396. If you ever wondered how likely it is that a certain event will occur, then you've wondered about probability. The probability of an event is the likelihood that the event will happen. Probability assigns a number to how likely an event is to occur. Or the chance it will occur. Probability can be expressed as a fraction, a decimal, or a percentage. In decimal form, the range of probabilities is from 0 to 1. That's inclusive. If an event has a probability of 0, then there is no chance of that event happening. I'm going to switch to a pen. If an event has a probability of 1, then the event is guaranteed or is certain to happen. The closer the probability of an event is to 1, the more likely the event is to happen. And similarly, the closer the probability of an event is to 0, the less likely it is to happen. For example, if an event having a probability of 0.78 is more likely to happen than an event having a probability of 0.14, because 0.78 is closer to 1 than 0.14. Basic probability vocabulary. An experiment is a process having a well-defined outcomes, like rolling a die. What are the possible outcomes? There are 1, 2, 3, 4, 5, or 6. An outcome is a result from a single trial of the experiment. An event is a collection of one or more outcomes. For instance, the probability of when rolling a die, it lands on an even number. There's more than one possible outcome there. There's 3 possible outcomes. You can get a 2, a 4, or a 6. Sample space is a set or collection of all the outcomes of an experiment. Our first example, we have an experiment is run whereby a spinner is spun around the circle with 5 equal sectors as shown. What is the experiment? Well, it's the process of spinning the spinner and noting the number that it lands on. List the possible outcomes of the experiment. Well, there are 5 possible outcomes, and they are, we'll list it as a sample space, so it's a set. 1, 2, 3, 4, 5. Those are the possible outcomes. How many possible outcomes are there? How many of these outcomes are odd? There's 3 of them that are odd, 1, 3, and 5. What is the probability of the spinner landing on an odd number? It's going to be the number of ways it could happen, which is 3, out of the total number of possible outcomes, 5. And that can be expressed as the decimal 0.6 or as the percentage 60%. There's 2 types of probability. Empirical probability. The empirical probability of an event is found through observations or experiments. It's the likelihood that an event will happen based on the results of real data that's been collected. This notation here, we read this as the probability of event E occurring. The probability of event E occurring is equal to the number of times event E occurs in an experiment divided by the total number of trials or observations. Our next example, we have a survey was conducted to determine students' favorite breeds of dogs. Each student chose one breed. We have this table, so 10 students chose Collie, 15 Spaniel, 30 Lab, 8 Boxer, 5 Pit Bull, 12 other. What is the probability that a student's favorite dog breed is Lab? Well, it's the number of students who chose Lab, which was 30, out of the total. Well, how many students are there that were in this survey? We're not told that, but we would have to add these all up. 25 and 30 is 55, 60, and 20, 80. So 30 over 80 is our probability, or we could reduce that, or the decimal, 0.375, or the percentage, 37.5%. Theoretical probability of an event is the number of ways that the event can occur divided by the total number of outcomes. It's finding the probability of events that come from a sample space of known equally likely outcomes. So the theoretical probability formula is always the number of favorable or desired outcomes divided by the total number of possible outcomes. For example, find the probability of rolling a 6 on a die. Well, the number of outcomes is 6 possible outcomes, and each one is equally likely to happen. And there's only one 6. So the probability of rolling a 6 is 1 out of 6. Find the probability of tossing a fair die and getting an odd number. We've got 1, 3, and 5 are odd numbers. So there are 3 possible odd numbers out of a total of 6 possible outcomes. Comparing empirical and theoretical probabilities. Al and Jen rolled 2 dice 50 times and record the results in the accompanying chart. So they're counting up the sum on the 2 die. What is their empirical probability of rolling a sum of 7? Okay, so how many times did the sum of 7 occur? 6, 8, 9, 10. I counted 13. Hopefully you counted the same. So it's number of times the 7 occurred, and their little experiment, which was 13 times, out of the total number of rolls that they did, which was 50. Or, let's see, that's 0.26. What is the theoretical probability of rolling a sum of 7? So here we have all the possible outcomes of when rolling 2 dice. And 1, 2, 3, 4, 5, 6. So it is likely that 7 would occur 6 out of, the square is 6 by 6, out of 36 times. So 7 occurs 6 times out of 36 possible. This is a decimal, approximately this is 0.16 repeating. Theoretically, what's the sum of rolling a 10? 1, 2, 3. And you can get that by, yeah, I didn't do that for the 7, sorry. You can get a 7 by a 6 and a 1, a 2 and a 5, a 3 and a 4, right? A 10 you can get by a 6 and a 4, a 5 and a 5, and a 4 and a 6. So this would be 3 out of 36 for the 10. How did empirical? That was when Al and Jen rolled the dice 50 times. How does that compare to the theoretical probability? Well, let's see if we can. These two, the empirical was slightly higher than the theoretical. In this example. Oops, sorry about that. There you go. Okay, now we're looking at set definition. Since the basic calculation within probability involves counting the number of outcomes that fit into a particular event, we need a way to visualize and keep track of all the outcomes in a sample space. We'll do this by using sets. Recall our basic definition of a set. It's simply a collection of things, numbers, objects, that satisfy a well-defined criteria. The things that are contained in a set are called the elements of the set. The set A is defined as a collection of all integers that are greater than 0 and less than 7. Write out set A in roster form. And so roster form, remember, is a listing. So this set A would be greater than 0, but less than 7 is 1, 2, 3, 4, 5, 6. These are integers greater than 0, but less than 7. A subset is any set whose elements are all contained within another set. Give 2 possible rules that could define subsets of A, and then write the sets as B and C in roster form. Okay, let's say set B's definition is going to be our even numbers, or more specific, our even integers of set A. That would be 2, 4, 6. Set C's definition, prime integers of set A. Your first prime number is 2. Right? Prime numbers have only 2 factors, the number 1 and the number itself. So 2's factors are 1 and 2, 3, 1 and 3. 4 is not prime because another factor of 4 other than 1 and 4 is 2. 5 is prime. 1 is not prime because it has only one factor, 1. Right? Prime numbers have 2 factors, the number 1 and the number itself. So 2, 3, and 5 are our prime numbers from set A. Do sets B and C have any elements in common? Yes, they do. They have 2 in common. So if I was to write this, we are going to get into drawing some Venn diagrams. So let me just try and draw a Venn diagram here. So this is set A. It contains all the numbers 1, 2, 3, 4, 5, 6. Set B contains 2, 4, 6, and set C contains 2, 3, 4. And since B and C both contain 2, 2 goes in the overlap space there. And in B we would have 4 and 6 inside, and C would have the 3 and 5. And the number 1 is not contained in B nor C, so 1 is outside of B and C, but still within A. So going back to probability, consider an experiment where we toss a coin and then roll a 6-sided die. Okay, so your outcomes on the coin are heads or tails, and your outcomes on the die are 1, 2, 3, 4, 5, or 6. Write a set of ordered pairs such as H, 4 that represents all outcomes for this experiment. Recall, this is called the sample space. We will generally call this set S. Okay, so we're going to say that set S is equal to the set containing H1. You get a head and a 1, a head and a 2, head and 3, head on the coin, 4 on the die, H5, H6. Or you can get a tail and a 1, tail and a 2, tail 3, tail 4, tail 5, or tail 6. Write a set of ordered pairs that represents the event of getting a tail and an even number. Call this set A. So we want a tail and an even number. So we get a tail even, so tail 2, tail 4, or tail 6. The complement of set A will be all of the events in the sample space that do not fall into set A. So it's everything in here except for T2, T4, and T6. So A complement, which is sometimes the complement of set A, we're calling set B. So we're going to say B equals, but the complement of set A, you might see like A with a raised C for A complement. We want all our H's and our T1, T3, and T5. Find the probability of A and the probability of B. All right, so the probability of A is, well, A has 1, 2, 3 possible outcomes out of the total in the sample space is 12. So it's 3 12s. The probability of B is 1, 2, 9 out of 12. What do you notice about these two? If we were to add these, you get 12 out of 12, which is equal to 1. So we have the statement, a set and its complement are important when we look at probability because all outcomes either fall into an event or its complement, but not both. So the probability of A plus the probability of its complement, I'm going to say A with the raised C, A complement, is equal to 1. Oh, and there was one other question here. Sorry about that. So there's one last question on page 375. So I was mistaken in the beginning. That means the homework must be pages 396 to 397. Try that once more. Homework's page 396 and 397. Answer each of the following problems by using relationship developed in the previous exercise. If the probability I will draw a red marble from a bag is 3/17, what's the probability that I won't draw a red marble? So oftentimes I always like using notation. So I'll say probability of red marble is equal to 3/17. Probability if it's not a red marble would be 1 minus the probability of red. And 1 minus 3/17, not that you have to do all this work, is equal to 14/17. If the probability that it will rain tomorrow is 20%, probability of rain equals 20%. What is the probability it won't rain tomorrow? Don't know if you, well, I'm going to say not rain. We know it's going to mean to be 80%. And these two, this is like rain and the complement of rain. They add up to 100%, which is equal to 1. Okay, so finally, a nice shorter video than what we had in Unit 11, our trig unit. So the 2 pages for homework, please. Thank you once again for your attention.